Hey you guys, super easy lesson today on percent composition. We are talking about percent composition here in this unit because it has to do with the mole. You'll see why in our next lesson. But percent composition is very, very simple. It's simply the mass of the element over the mass of the total portion of the compound, just like a percentage of anything is a part out of a whole. The reason why percent composition is really important for us is because it helps us determine the identity of compounds. So, percent composition is the mass of each, maybe I should say mass proportion. It is the mass proportion of each element in a compound. We learned about this when we, in our very first unit, talked about the law of definite proportions or constant composition, that if you have a substance that has identical percent composition to another substance, then you know it's the same compound. So the way that we calculate percent composition is we take the mass of the element that you're referring to in the compound, and you put it over the mass of the entire compound. That's your proportion, and of course to turn it into a percentage you multiply times 100. So for example, if we were looking at magnesium chloride and we wanted to calculate the percent composition, the first thing that we need is the entire molar mass of magnesium chloride. So magnesium has a molar mass of 24.3 grams per mole. And then we're going to have to multiply 2 times the molar mass of chlorine, which is 35.5 grams per mole. Pull out my calculator here. Hopefully you're calculating along with me so that you're not totally bored and falling asleep. 24.3. More importantly, checking my work because I am prone to error. And here we go, a molar mass of 95.3 grams per mole. So that's the molar mass of the entire compound. The percent composition will tell us what percentage of this compound is magnesium and what percentage is chlorine. So to do that, we're going to put magnesium's mass, the 24.3, over the mass of the total, 95.3, and multiply by 100. And I get 25.5%. And then to get the mass of the chlorine, I'm going to do my entire mass of chlorine, so my 2 times my 35.5 over my total, 95.3. And I get 74.5%. Now, a quicker and easier way of calculating that other percentage would be to just subtract from 100, because all of the percentages have to add up to 100. Now, of course, due to rounding, it might be slightly off, but for the most part, you're going to get pretty close to 100% when you add up each portion of the element in the compound. And like I said before, if we were to come across another compound that was 25.5% magnesium and 74.5% chlorine, we know that that compound was, in fact, magnesium chloride. Let's do one more example. Percent composition for magnesium phosphate. Well, the first thing we need is the molar mass of the entire thing. So 3 times my 24.3 for my magnesiums, plus 2 times my molar mass of phosphorus, right? Because I have 2 phosphates. Now you could get the molar mass of phosphate and multiply that whole thing times 2, or you could distribute the 2. So I'm just going to distribute. The molar mass of phosphorus is 31 grams per mole, plus 8 times the molar mass of oxygen, which is 16. So 3 times 24.3 plus 2 times 31 plus 8 times, oops, I needed parentheses. I almost messed up my order of operations here. 8 times 16. And I get a molar mass of the entire compound as 262.9 grams per mole. So to get percent of magnesium, I'm going to put my 3 times my 24.3 over my total, 262.9 times 100. To get my percentage of phosphorus, I'm going to put my 2 times 31 over my total, 262.9. And to get my percentage of oxygen, I'm going to do my 8 oxygens over my total times 100. Oh, I've kind of run out of room a little bit. Sorry about that. Okay, so 3 times 24.3 divided by 262.9. And I get 27.7%. Maybe I'll go ahead and put these in a different color since I got a little squishy on my rim here. So my magnesium is 27.7% magnesium. And 23.6% phosphorus. And finally, my oxygen. $48.7. Let's go ahead and put it up here. 48.7% oxygen. So there's my oxygen, there's my phosphorus, there's my magnesium. Let's add all those up and make sure we get close to 100. Just a good way to double check to make sure we didn't do anything goofy here. And we get 100%. Perfect. So those are super easy and simple calculations, right? Percent composition is the mass of the element over the mass of the entire compound. And the reason why we care about percent composition is because we're going to actually be able to work backwards from percentages to figuring out the formula of the compound. And that is in fact how scientists discover the formulas of unknown substances. You know, you bring something back from, a trip to the jungle, or you bring back a substance from the moon even, and you can run that substance through a laboratory procedure to determine its percent composition. Once you know its percent composition, you can work backwards towards the formula to identify what that substance is. So that's why this is important to us, and we will do that type of calculation next. Are you looking forward to it? Those are actually some of my absolute favorite types of chemistry calculations, determining empirical and molecular formulas from percent composition. Maybe I'm just a huge nerd, but I hope that you guys are looking forward to it. All right, bye-bye.